Hello, welcome to the video notes for lesson 5.3. This lesson is all about the slope of a line from a graph. Okay, so our target for this lesson is I can find the slope of a line on a graph and find the slope of a line given 2 points. So if you're either given a graph or even just the points, you should be able to find the slope, which remember we use in our equation, and that the slope is our rate of change, and it's a very important part of linear functions. So, slope. The slope of a line is the ratio of the vertical change to the horizontal change. By the way, these notes begin on page 13 in your notes packet. So, vertical change. Remember, vertical change is represented by delta y. Vertical is going up and down. And horizontal change, delta x. Okay? So, slope looks kind of like this. It's the change in y over the change in x. Now this definition down here that I just read is kind of a fancy way to say it when it uses words, math words like the ratio, vertical change, horizontal change. Alright, and we've talked about this over and over in math, so this should not be new to you. Remember, in the equation, it's represented by m. M is not a variable, it's like a placeholder. Remember, it's the number in front of the x value. And then slope. Okay, so what does that mean? Well, so change in y over change in x, that's what we use if we have a table or if we have 2 points. M is what we use if we're dealing with an equation. And slope is what we're dealing with when we're talking about a graph. Alright? Okay, so this is an example right here. So we have the slope is equal to the vertical change over the horizontal change. Remember, we talked about that as delta y over delta x, change in y over change in x. Here's another way that you will hear this. This is like an old school way of remembering it. It is called the rise over the run. If you think of rise, and when something rises, it goes up. If it rises negatively, it goes down. So up and down is the vertical change. Run is side to side. Okay? So that's why it's the x. So rise over run is a way of remembering change in y over change in x. Alright? And then when you look at this graph, so we start at a point and we go to another point, and then up 3 units, that's the rise. So it rises, it's going up, so it's a positive 3. And then right 2 units, that's the run. Since it's going to the right, that's positive. So that's why we get positive 3 over positive 2. Now you can simplify it, but if we want, you can also leave it as a fraction, which is what you'll see happening quite often. Alright, so let's talk about what's at the bottom here. You can find the slope by determining the change in y and the change in x from one point to the next, which I just talked about, or make an itty-bitty table. I actually prefer, instead of, not itty-bitty, little bitty, or I prefer mini table, a mini table with 2 coordinates, and then you find your change in y over your change in x. And again, we have another example here. Now, I don't like this example because it makes it look like we're going from this point to this point. I always do the it doesn't matter which point you're going to, but I always do the rise over the run first, the change in y over the change in x. So if I'm going to go from this point to this point, I'm not going to go to the right first. I'm actually going to go up and down first, which is actually down 3, so minus 3. And then over, or run, plus 6, because I'm going to the right. So then you get your negative 3 over positive 6, which is negative 1/2. There's your slope. All right? Let's take a look at page 14. We have some examples we can take a closer look at. So, we have animal speeds, and these ones are already graphed for us, the cheetah, the lion, and the rabbit. Over here we have like a table, or a different kind of a graph. Not really a table, more like a different kind of a graph that shows some additional animals, plus the ones that are listed here. Obviously, if you didn't know, the cheetah is the fastest animal on the planet. For each animal graph, pick any 2 points and find the slope of the line. Alright, so you can do that. Before we pick the 2 points, what I'm going to do is show how you can, so I'm going to do this 2 ways. I'm going to do the graph, and then I'm going to do the mini table. So for the graph, I'm going to start at the origin, and I'm going to go to the first point for the cheetah. And I go up 70 over 1, rise 70, run is 1, so 70 miles over 1 hour. Now if I want to do a table, I can actually use the origin and this point here. Watch what I get. So I get X and Y. So the origin is 0, 0. This first point is 1 and 70. So find how much the X value is going up. It's going up by 1. The Y is going up by 70s. So change in Y over change in X is 70 over 1, or 70 miles per hour. Okay? Really? Alright, so now let's try the line. So again, I'll start at the origin. I'm going to go to this first point here. So I'm going to go up, and it's in between 60 and 40, so that's 50, and over 1. So my graph is 50 miles, that's the rise, over the run, which is 1 hour. Now I'll use the table strategy. I'm not going to write table again. X and Y. Again, I'm going to use my 0, 0 and my 1 and 50. What's the rise or change in Y is plus 50. So I have 50 over change in X plus 1 over 1, or 50 miles per hour. Now for the rabbit, I'm going to do the graph the same way. So the rabbit's right here. Now this one might be a little trickier. So the rise is about halfway between 40 and 30. So it looks like 35, and then the run is 1. So 35 miles over 1 hour. Now we can confirm that by doing the table. Now for the table, I'm going to do something different. I'm going to use this point because I can tell what it is, and I'm going to use this point here. So the first point is the X value is 2, the Y value is 70. So I have 2, 70. And then the second point, the X value is 4, and the Y value is 140. Alright, so watch what happens. So this is increasing by 2s, this is increasing by 70s. So my change in Y over change in X is 70 over 2. 70 divided by 2 is 35 over 1, or just 35 miles per hour. And this confirms what we found when we did the rise over the run. So the reason why I showed you something different here, we could have also used the origin for this, but I wanted you to see that it doesn't matter what 2 points you use, you can always find your rate of change as long as it's a linear function. Alright? Any 2 points you want. One more thing, draw a line to represent the zebra's rate of speed. So the zebra, if you look at the table, is 40 miles per hour. So what I did for this is I found a different color. Again, at 0, it's 0. Then I put a point here, 1 and 40, 2 and 80, 3 and 120. And then go ahead and then make sure you connect your points with a nice straight line. And then make sure, if you do arrows, now notice this graph didn't do any arrows. They probably should have put arrows on the end. Oh, and by the way, it is a connected dots because it's continuous. There's going to be stuff in between. Okay, so next page, page 15. Identify the slope of the line using graph, or I knew it said itty bitty table. I don't like itty bitty. Mini table. Okay. Alright, so if we're going to use the graph, you do your rise over run, and the rise over the run. So I'm going to start at this point. It rises 1, 2, 3 to get up to here, and then it runs 5. So it's going up, so that's plus 3, and then it's going to the right, so that's plus 5, positive 3 over positive 5, and then just leave it like that. That's your answer. If we're going to use a table, it'll be, get your x and your y, find your point, so the one point is -2, -2, the other point is 3, 1. Find your change in y, so from -2 to 3, change in x. From -2 all the way up to 3 is plus 5. And then from -2 up to 1 is plus 3. So change in y, delta y over delta x. Now one thing students get mixed up is they put the wrong number in the wrong spot. So for me, I've just gotten so used to the number over here on the right side, because I always put my y values or outputs on the right side of my table, is the one that's going on top, and the one over here is the one that's going to go on the bottom. But examples that you're going to find aren't always that nice, so make sure that you pay attention to what numbers you're working with. Alright, so we have 2 more examples. The one on the bottom is kind of sneaky, so I might be interested to see if anybody can actually figure this last one out. We could go over it in class and I can show you the answer, but why don't you, so for a couple extra points, figure this one out. Actually, these last 2, because there's no points on here. So you're gonna do the rise over the run first. I'll help you set it up. Rise over run equals, and then do a mini table, x and y, and then find your change in y over change in x. I will give you a hint with this one. It's a negative value. The one down below, I'm not going to give you any hint other than it's a little tricky. Alright, so same thing, and then do a table just to, almost like as a check to confirm what your answer is when you do the rise and the run. Alright, that's it. The video is getting a little long, so I'm going to stop it here. With these last 2 that I didn't finish, I expect you to try them. It's okay if you get them wrong. If you don't understand something from the video, go back and rewatch it. or come and see me, or see a friend or a parent for help. All right? Good luck, and we'll see you in math.